All right, so I'm gonna show you how to initially start this activity. Um, I know there are a lot of limitations possible. For instance, you might not have colored pencils. You might not have a printer where you can print this out. So first off, if you have colored pencils, then there's no limitation, and a printer. If you don't have colored pencils, you can just write in the color and give it a shading. If you don't have a printer, it's going to take you a little bit longer. So I'm going to ask that you take the document and and write in or color in the boxes throughout your document. And I know that that's going to be tedious and long. That's why I'm going to give you a long period of time to complete this. All right. So um, basically what we're going to do is we're going to take table M and we're going to create a color scheme for every single pH from 1 to 14 using the ranges of what I've taught you as well as all 14 pHs. So I'm going to do two of them with you. I'm going to do methyl orange and I'm going to do litmus. Right, so I really suggest you follow with me and then you go and do the rest of this and the rest of the activity on your own. So I look at methyl orange and I realize that it goes from red to yellow, and the color change of red to yellow is going to be orange. So I take the information I've already taught you, which was everything leading up to 3.1 is going to be red, and everything after 4.4 is going to be yellow, meaning everything in between 3.1 and 4.4 is going to be the color change from red to yellow, which is orange. And then I just make the colors on here. Now, I'm not going to make this super duper artistic, but I know some of you are really good at shading and drawing rainbows. So knock yourself out because that always looks really, really nice. So I'm going to start off by marking my range of where red stops and where yellow begins. And then I'm just going to shade the whole area according to that color. So everything leading up to 3.1 is red. And everything after 4.4 is yellow. I'm just going to shade that in. This is going to be a really good resource for you because you're always going to have this in front of you to be able to say, oh, a pH of 8 in methyl orange is yellow. A pH of 2.7 is red. A pH of 3.8 is orange. And you're going to have this nice little color-coded indicator with you all the time because I won't be collecting it anytime soon. Litmus is the other one I want to do. So what you should do instead of doing all of this is just take the information, right? So the first color change is going to happen at 4.5. So I'm going to find 4.5. I'm going to find litmus, and I'm going to put the line right there. I'm going to find the second number where the second color change is going to occur. I'm going to go to 8.3. I'm going to go to litmus, and I'm going to put the line. So what I've done is I've decided and I've figured that anything before 4.5 is red, anything after 8.3 is blue, which means that in between phase is red to blue, also known as purple. And so once I do that, I can color in the segments accordingly. And get a beautiful indicator spectrum of litmus across the whole pH scale. Now, that might look blue to you, but it's definitely purple. So this is what I was saying before about litmus. Litmus is a really good indicator of if something is acidic or basic, because if it's one color, it's definitely a base. If it's red, it's definitely an acid. If it's purple, it could be either, but we're just trying to determine if it's strictly a base or strictly an acid. And that's different from the methyl orange up top. I'm just going back into what I was talking about before. It's a terrible indicator for finding out if something's an acid or a base. Because you can see if it's yellow, this is the neutral point, right? If it's yellow, it still could be an acid. We don't want that. You might be asking, why do we use methyl orange then if we don't want to, if we don't get that information? Because methyl orange has a different purpose. Its purpose is to tell, I already know the substance is an acid. Let's just assume I already know it's an acid. Now I can determine how strong of an acid it is. Yellow would mean that it's a weak acid. Orange would mean that it's a pretty moderately strong acid. And red would mean that it's very, very strong. So each of these indicators have different purposes. They're not only to tell me if it's an acid or a base. As in the case of methyl orange, it's telling me how strong of an acid that it actually is. Okay. Last thing, a lot of people ask, and you're not going to have the opportunity, what is the color change from colorless to pink? I have no idea. There's no colorless to pink. The answer is light pink. So you're just going to do a nice light shading. All right, and that should be good enough for you to get going on this. I want you to take your time. Please ask questions if you can. And that's going to wrap it up for this. All right. Thank you. I will see you. You will see me next week. All right.